What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor.
What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be continuing our discussion on SN2, SN1, E2, and E1 reactions. Now, I want you guys to work on these problems, give them a try, pause the video, and predict the major product, okay? And then unpause the video, and we'll go ahead and discuss them together. All right, let's jump in. So, I know that this sodium is positively charged spectator ion with a negatively charged oxygen. Here's my OCH3. That's going to be negatively charged. So I have an OR group, and this carbon is going to be, what do you think? Is it primary, secondary, or tertiary? Yeah, this group is going to be a secondary carbon. Okay, so if I refer back to that table, remember I posted a video a couple videos ago. Go ahead and check it out if you haven't already. It's going to show you this nice table that's going to help you walk through most, if not all, of the problems you'll see when you're doing these reactions, okay? And then continue to build your own table as you see more examples. Just add it to your chart, okay? All right, so this is secondary. We have a good nucleophile. This is a strong base. So I know that this is going to go through what type of reaction? Yeah, it's going to go through an E2 reaction, E2. So what does E2 like to do? Well, since we're doing elimination, we're going to have to eliminate our leaving group, and we're not going to substitute it, right? Because that would be a substitution reaction. E2 is referring to that we're going to have a bimolecular state, which means in one fleeting moment, this oxygen is going to be forming a bond with this hydrogen, and this Cl group at the same time is going to be kicked out. So you can imagine its transition state is going to look something like OCH3. Here's our hydrogen, and then our chloride at the same time is getting kicked out. Okay, something like that, right? That's what the E2 is referring to. Anytime it's E2, SN2, it's all happening in one step. All right, so what's our major product going to look like? Well, we're going to have something that looks like this. Our Cl is no longer there, and we just formed a pi bond. Now, we could have grabbed hydrogen A or hydrogen B, would have been the same exact thing, okay? And then, so side products would be HOCH3 and Cl minus. Perfect. All right, let's go ahead and move on to the next problem. Down here, I see that I have a, what type of carbon do you think this is? This is going to be a, again, secondary carbon. Perfect. And then our reagent, so this is going to be pretty special. I enjoy working with this. This is our big, bulky base, all right? So they could throw many types of big, bulky bases. You just have to recognize that this is a hindered reagent. So when we react this with our substrate, it's not going to be able to fit into here and do a SN2. No. It's going to want to grab something that's pretty small and pretty far out the way. So it's going to want to grab a hydrogen. It's going to want to grab a hydrogen. But now I'll ask the same question that I did earlier. Can we grab hydrogen A equally with hydrogen B? Looks like we could, right? Because we have on this carbon a CH3 group coming off of it, and coming off here we have a carbon, and then we have a CH3 coming off of it, right? So it looks similar, like we could grab either or. But in this case, which one do you think we're going to grab with the big bulky base and the geometry we have with our leaving group? What do you guys think? Well, I'm going to introduce something called antiperiplanar configuration. Okay, now this means that our big bulky base is going to want to grab something that's as far away as possible from our leaving group. So if our leaving group is pointing out of the board, it's coming at you, then the big bulky base is going to want to grab a hydrogen that's going away from it. Notice how this one is 180 degrees pointing away from the board, while this one is coming out of the board. Okay, so these are as far away as possible from one another. That means that this group is going to want to grab this hydrogen, not hydrogen B. All right, so when that happens, I can take this hydrogen, form a pi bond right over here, and then kick our Br group out, just like that. All right, so then our major product is going to look like, here is our major product. And now notice, we still have a CH3 group coming off of here, but this is a sp2 hybridized carbon. That means this is going to be planar. This is 120 degrees totally flat. All right, this carbon right in there, and this carbon over here, this is going to have the same geometry still. This is still our CH3 pointing away from us. All right, so we can only grab hydrogen A in this case. And this was also through the E2 mechanism. All right, that's everything for today, guys. I hope that was helpful. Keep practicing and keep building your own table. All right, thanks, guys. See you next time.